Alright, one method to solving a system of equations is using elimination. The other two are graphing and substitution. Elimination actually uses a method to eliminate a variable in its entirety so that you can solve for the other one. So elimination's also been referred to as adding the equations because it's essentially what you're doing. So you can use this to solve by adding terms vertically. So that means just line them up together and you can solve them by adding straight up and down. So when I take this system of equations, I see that I've got the plus y and the minus y. So these have the same coefficient but different signs, and that's a good thing. That's what we're looking for. So when I add them straight down, I go 3x plus 5x equals 8x. Plus y minus y is 0. And then I've got to add these straight down, and 6 plus 10 is 16. So now I'm left with 8x equals 16, and I can figure out what that x value is. So you can eliminate and then you can solve for x. So in this case I've got 8x equals 16. Divide both sides by 8 and x equals 2. Alright, now I'm going to plug the 2 back in for an x value and I get 3 times 2 plus y equals 6. So 6 plus y equals 6. Subtract both sides and I'm left with y equals 0. Once you have one letter, you could figure out what the other one is by plugging it back in, and then you always need to check your work as seen in previous videos. So another type of elimination may require you to multiply so that you can get the same number top and bottom. So for example, if we look here, I've got 2x plus 5y equals 9. Well, you've got to make a decision about what you want to eliminate, and if this just had a negative 2 in front of it, when I added them, the x's would go away. So what we're going to do is multiply everything in this equation by negative 2. So I'm going to rewrite my 2x plus 5y equals 9, and now I'm going to multiply negative 2 times the top and the bottom. After you distribute all of that, you get the negative 2x plus 6y equals negative 20. So that when you add them, the 2x's go away, you get your 5y and 6y, and that equals 11y, and then 9 minus 20 is negative 11. You can see that y is going to equal negative 1. Last elimination may require multiplying both equations by different numbers. So if you take a look at these two equations as an example, I've got 5x plus 3y equals 2 and 4x plus 2y equals 10. Well, there's not a number that I'm going to multiply times either of these to make it look like the top one, just a different sign. So what we're going to do is we're going to pick which letter you want to eliminate. It does not matter which one. If you decided you wanted to eliminate x's, you'd multiply the top by negative 4 and the bottom by positive 5, or change the signs to make that different. This example, this group wanted to get rid of the y's, so it multiplied the top by negative 2, which made this negative 6y. It multiplied the bottom by positive 3. If you made the 2 positive and the 3 negative, that's okay too, as long as one of them ends up being negative, so that when you add them straight up and down, you end up canceling something out. So when I multiply 2, I get negative 2, I get negative 10x plus negative 6y equals negative 4. Then I would get 12, 6y, and 30. So when I add these straight up, the y's will go away and I get 2x equals 26, and I can easily solve for x by dividing by 2. So x would just equal 13. You would plug that back into an equation to figure out what the y equals. So let's see what one looks like from start to finish. Alright, so I want to see what I can eliminate here. What I see is if I multiplied this top one by a positive 2, I would have a negative 2y and a positive 2y, and those would cancel out. So I'm going to rewrite, I'm going to multiply everything in here by 2, so it's going to multiply times everything. So I get 4x minus 2y equals 40, and I'm just going to rewrite the bottom one, making sure everything's still lined up. 3x plus 2y equals negative 19. I'm going to add straight up and down, and I get 4x and 3y is 7x. The 2y's cancel out. 40 minus 19 equals 21. Divide both sides by 7, and I'm left with x equals 3. So I'm going to go back to my original equation here, and I'm going to plug in the 3. So 2 times 3 minus y equals 20. So this is 6 minus y equals 20. I'm going to subtract 6 from both sides. Negative y equals 14. Divide both sides by negative 1, and I get y equals negative 14. So the answer here is 3, negative 14. I know this is correct because I have the answer key, but please don't forget to go back and check your work by plugging in this point to both of your equations. Alright, so for number 2, I see that I have a positive 2y and a negative 2y, so I can just go ahead and add straight up and down, and I get 3x plus 3x is 6x. 2y minus 2y, that goes away, it cancels or eliminates, and I get 10 plus 14 is 24. I'm going to divide both sides by 6, and I get x equals 4. So to figure out what the value for y is, I'm just going to plug that 4 into the top equation, and I get 3 times 4 plus 2x equals 10. This is 12 plus 2x equals 10, so I'm going to subtract 12 from both sides. And I get 2x equals negative 2. And when I divide both sides by 2 to get that x all the way, or excuse me, I keep saying x, these are both y's. And this last one down here is a y as well. When I divide both sides by 2 to get y by itself, I get y equals negative 1. So my point is 4, negative 1. Again, don't forget to plug this point in to check your work, but just so that the video is not too long, I'm going to just leave the answer and not go back and check. So when I look here, I need to make a decision about what I want to eliminate. The y's look really, really similar. It's just they're the same sign and they're supposed to be different signs. So I'm going to multiply this top portion right here by negative 1. So I'm going to get negative x minus y equals negative 12. And I'm going to rewrite the bottom. I get 2x plus y equals 6. So when I add these up, negative x and positive 2y just equal positive x, or excuse me, 2x just equal positive x. And then negative y and y added together cancel out. And negative 12 plus 6 is going to be negative 6. So now I'm going to take this negative 6 value and plug it in for one of the x values up here. So if I plug it into the top one, I get negative 6 plus y equals 12. To get the y by itself, I undo negative 6 and do positive 6. So y equals 18. So my answer is the point negative 6, 18. Alright, just one more. The last one here, I see that everything is lined up nicely, but I'd like for these y's, one's negative and one's positive already, which is a good thing, but I'd like for this to have a 2 in front of it. So in order to get the 2 in front of the y, I have to multiply everything in the top by 2. As I multiply it, I'm just going to write it beneath this other problem this other equation that I have. So 2 times 3x is 6x. 2 times negative y is negative 2y. And 2 times 2 is 4. I'm going to add them. So negative 8 plus 6 is going to be negative 2x. My y's will cancel out. And then I'm going to say 4 plus 4 equals 8. Divide both sides by negative 2. And x equals negative 4. To figure out my value for y, I'm going to plug that back in. So negative, I'm going to plug it into the top one. So 3 times negative 4 minus y equals 2. So negative 12 minus y equals 2. I'm going to add 12 to both sides. So negative y equals positive 14. Divide both sides by negative 1 and I get y equals negative 14. So my answer for this problem is x equals negative 4 and y equals negative 14. Again, you can always plug them back in to check your work. Sometimes when you're trying to use elimination, it doesn't seem like it's very easy to use elimination because they're not set up necessarily ordered together. And you look at it and you think, well, maybe substitution would be easier. So really, when you have a system of equations, it can be solved by graphing, substitution, or elimination, and it doesn't matter which one you choose. So if I took a look at this one, you see that one equation is already solved for a variable. So in this case, you'd want to use substitution because half the work is done already. If you take and compare it to this one over here, we see that your y's would cancel very quickly if you just added them together. So this one would use elimination. Graphing would be a really good choice if they were both already solved for y. So because you can see your y-intercept and your slope, and you can just plug them in and graph them very quickly. So if you take a look at, and these are just examples of a substitution and an elimination problem which we've already seen. So if we take a look at these, let's just, instead of actually working them all out and solving them, we'll do that in class. But now I just want to pick which would be the best method to use. So in this problem, I see that the y is already by itself. So what we're going to do is we're going to say, well, since the y is by itself, it would be very easy to substitute that in here. So I'm going to make this substitution. For this one, this has a positive 1y and a negative 1y. So this would be a really nice candidate for elimination. This next problem here, you could really go either way. It would be a personal preference. If you multiplied this whole top by -5, it would be a very quick elimination problem. Or if you subtracted the 2x, it would be a very quick substitution problem. So this one would be either substitution or elimination. And it is a personal preference. Just remember that every time you solve, you can check your work by plugging your answer into both equations. Okay, by plugging it into both equations, you can verify that you're correct before you even turn in your test or your quiz, and you can already know what your grade will be.